Okay, hello, Professor. My name is James, and today I'm gonna talk about the lab 3 assignment. So, in this lab, the goal of this lab is for us to implement the circuit that can drive the time multiplex um, was 7 segment display present on the real digital blackboard. And so, on this lab, we have um, we have 4 inputs. Um, we have 4 input value from the switch, and then we have the clock signal input also, and we will have for output of the display assessment, the seven assessment display, and also a output port present assessment. And we will have the decimal, 4 decimal um, clock clock counter, and 2 bit counter also. And then um, and there is have the clock input plus an input bus for each digit to bring 4 bit binary value to be displayed. We have the clock signal and value uh, for the leftmost and left center, right center, and the rightmost to display the digits 0, 1, 2, and 3, and and uh, and for the control signal, we're gonna create the block for the detect the positive edge of clock signal, and it will be increase clock counter by 1, and we have the if clock counter reach limits, and we wanna store the switch value, and below we have to create we have 4 case of counts to turn on um, uh, digits 0, 1, 2, and 3, and below we have the hexadecimal to segment converter. We need to display from 1, 2, 3, 4, 5, 6, 7, 8, 9, and A, B, C, and F. And the last one is about a logic control the decimal point based on the status of certain input signal and counter variable. So mm, if the button low, the decimal not displayed, and if the dark signal is 1, the button is not held, then the decimal point will display. And here we're gonna have the test pen. We have the 7 adjustment display node and 8 output ports, and also the input value from the switch. And we have the interface. We're gonna set up the segment module, and here to display display the simulation. And we're gonna have the constraints. So now let's run the simulation. And run the synthetics. Now run the implementation. Now run the change the bitstream. Now time to simulation. You see here when the switch one is on, the summon displacement and so on. When switch second is on, we will choose. If the switch one is off, we shall choose when all of them. For the first one switch is on, the summon displacement is so F. It means the 15, and and for and eight A note is on, the 7 difference so to F. So when 12 note is on, the 7 segment so 3F, and all notes is on, the displacement so let's see, about 6F and 5 4F. Two, 1F, 1F, 1FF, two on, AFF, 2AFF, 1FF, AF, A0FF. So I think I'm done with the simulation. So so after this assignment, the student can will have develop a piece of intertextual property that we may review in future. And after this lab assignment, student can know how to display the seven segment and know how to write the code to um, control the clock signal and display the digits also. Mm, um, and and after that, um, student can feel confident on on the design is working properly before we implement. I think that's it for today. Thank you, Professor.